this module, you will learn about the propagation of sound. How does sound propagate? To reach the listener's ear, sound needs to propagate from the source to the listener through a medium. A medium is the matter through which sound is transmitted. A medium can be liquid, solid, or gas. To understand the process of the propagation of sound, let's analyze what happens when a vibration produces sound. Now, let's see. What happens when we stretch a rubber band and tuck it in the middle? The air particles of the medium that are in contact with the vibrating rubber band, that is, the source of sound, are first displaced from their state of rest. These air particles displace their neighboring particles and then come back to rest in their original positions. Thus, another set of particles of air between the vibrating rubber band and the listener are in a state of vibration. These particles vibrate in a direction parallel to the line joining the rubber band and the listener. They, in turn, displace neighboring particles before returning to a state of rest. This process continues until the sound reaches the listener. Thus, particles of the medium do not move from the source to the listener, but it is the disturbance in the particles that is carried forward to the listener. This kind of a disturbance is called a wave. In other words, a wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into vibration. Therefore, we visualize sound in the form of waves. Air is the most common medium through which sound propagates. To study the form of a sound wave in more detail, let's use a tuning fork. Vibrating a tuning fork produces a small audible sound. Vibration involves the to and fro motion of the prongs of the fork about a fixed point. This fixed point is also referred to as the mean position. The vibrating prongs of the tuning fork push and compress the particles in front when moving outwards, creating a region of high pressure. In this region of high pressure, the density of air is higher than normal. This region of high pressure is called a compression. When the prong moves backwards, it creates a region of low pressure, called a rarefaction. In this region, the density of air is lower than normal. Thus, as the tuning fork vibrates, the to and fro motion of its prongs creates a series of compressions and rarefactions in the air between the fork and the listener. These compressions and rarefactions comprise a sound wave that propagates through the medium. As sound waves travel as disturbances propagated through the air by a mechanism of particle-to-particle interaction, they are termed as mechanical waves. Mechanical waves require a material medium for their propagation. This brings you to the end of this module on the propagation of sound. In this module, you learned that sound propagates through a medium. Medium is the matter through which sound is transmitted. Sound waves are mechanical waves.